real valued function whose domain is sample space. So what is a sample space? For example, we take tossing of two coins. So if we toss two coins, we get sample space as head, 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 tail, tail, head, tail, tail. Now if I define a random variable here, x is number of heads. So if you see the sample space, there are four elements in sample space. This is its domain. So x of HH is 2. Number of heads are 2. X of HT is 1. X of TH is also 1. And X of TT is also 0. So basically here random variable I have defined as number of heads. Now I have taken input from the domain of sample space, and I have seen what are the outputs. Outputs are real values. So these are the outputs. So this is how we define a random variable. Now next thing is probability distribution of a random variable. So here only if we see probability distribution, so it would be like x p. Now x values, as you can see above, has come 0, 1 and 2. In how many cases we are getting 0? Only one case out of 4 cases. So probability of getting x is equal to 0 is 1 by 4. How many cases we are getting value of x as 1? 2 cases out of 4 cases. So probability of getting x as 1 is half. How many cases we are getting the value of x as 2? So we are getting only one case out of 4. So this is the probability distribution. For x is equal to different values of x. R we generally write it as. Have you understood this?
Yes.
Okay. Now, after knowing probability distribution, we have mean of a random variable. So mean of a random variable, let us discuss. So it is actually xi into pi sum. That is, in above case, if you want to find the mean, x is equal to 0 into its probability 1 by 4 plus x is equal to 1 into its probability half plus x is equal to 2 into its probability 1 by 4. So you'll get half plus half 1. So here mean of the random variable is 1. Similarly, you can take some other example also. Now, let us take another example that let a pair of dice be thrown. What we are seeing, pair of dice thrown. So how many outcomes are there? 36 outcomes will be there. And the random variable x be the sum of the numbers that appear on the two dice, find the mean or expectation of x. Mean and expectation is same thing. So sum could be 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I'm not writing sample space. I'm writing sum. That is the values of x that can be taken. X values will come out to be this. Two, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Now the probability. So if x is equal to 2, the outcome is 2. How many cases are there where you will get sum of the numbers from the two die as 2? Yes. How many such cases will be there?
So 1.
Yeah. So 1 out of 36. What one? How many numbers will be 3?
1. So it's 1 for all.
No, it is 2 now. 1, 2 and 2, 1. In first die 1, in second 2, or in first to second 1.
Yes, sir.
So it would be 2 by 36. That is 1 by 18. How many times, how many ways we can get 4 as the sum of the numbers?
1, 3, 3, 1, 2, 2.
So 3 times. So this will become 1 by 12. 3 by 36. And what about 5?
So 4.
It will be
4 by
4.
30.
4 by 3, that is 1 by 9. If we come to 6, what will happen? 5, isn't it?
Yes, sir.
And 7, we will get 6 by 36, right?
Yes, sir.
It will be 1 by 6. 8 will again get 5 by 36. It will behave as for 6. For 5, 1 by 9, 1 by 12, 1 by 18, and 1 by 36. This is how it will behave. Is it okay? Now you can
Yes, sir.
also check whether you have calculated it correctly, because the sum of these probability sigma of pi must be 1, because there is no other outcomes of x. So if you will add them up, like 1 by 36 plus 1 by 36 will be 1 by 18, and then 1 by 18 plus 1 by 18 is 1 by 9, then 1 by 12 is 1 by 6, then 2 by 9, then 10 by 36, then 1 by 6. This is 5 by 18. This will become 5 plus 1, 6 by 18, that will be 1 by 3. And then we have 1 by 6 plus 1 by 6, 1 by 3 again, and 1 by 3 again. So it is coming out to be 1. So our calculation is correct. Now, if it is asked what is the mean, what we will do, simply we will multiply 2 with 1 by 36. So I'm not doing the calculation here. I'm just trying to explain another case also, because we took only one example. 4 into 1 by 12 and so on. 12 into 1 by 36. So this will be the mean. So these things we have to know in this random variable and probability distribution. Variance is not in the syllabus, so we don't have to do that. So in 13.4, you can try the question. So you can do question 2, 6, 8, 9, and 14. Just try these questions, 5 questions.
Oh, it's exercise 13.4, right?
Yeah, it's just exercise 13.4.
Oh, so I'm not able to do the second one.
Okay. It says that an urn contains 5 red and 2 black balls. So there are 5 red and 2 black balls, right? 2 balls are randomly drawn. Let X represent the number of black balls. So 2 balls are randomly drawn. X represent number of black balls. What are the possible values of X? Is X a random variable? So when you take 2 balls, you can get either 0 black balls, or you can get 1 black ball, or you can get 2 black ball. So yes, X is a random variable and its values are 0, 1, and 2. Probability they are not asking. If they would have asked the probability, that also you could have got probability distribution. Like if you get what is the probability that you get zero black ball. That means both the balls which are coming are red. So 5C2 by 7C2. What is the probability that the balls are coming one black and one red? That will be 5C1 into 2C1 by 7C2. And if both are black, then it is 2C2 by 7C2. Have you got this?
Yes, sir.
Even if you can check also whether your answer is correct, though probability distribution is not asked. P 5C2 plus 5C1 into 2C1 plus 2C2 by 7C2. You add them up. You get here as 5 into 4 by 2, 10. Here you get 5 into 2, 10. Here you get 1. In the denominator, you get 21. 21 by 21 is 1. So this probability distribution is also correct. Is it okay?
Yes, sir. So I'm not able to understand this concept. So can you like teach it again?
Yeah, sure. I will give you this example. If you haven't understood by heads on devices, you can do one thing that, like here, let us see that it is 5 black balls plus 2 red balls. This is what it was given here, no? 5 red plus 2 black. So let us do it slowly. There are how many balls? 7 balls. Now, X is a random variable which returns that number of black balls drawn. Now, you are in the experiment, you are drawing 2 balls. This is the experiment out of these 7 balls. So if it is asked, what are the number of black balls drawn? So out of these 7 balls, uh, you can get, if you are drawing 2 balls, you can get either 0 ball, black ball, or you can get 1 black ball, or you can get 2 black balls. Like if you get 0 black ball, that means you are getting 2 red balls. If you are getting 1 black ball, that means you are getting 1 black and 1 red. And if you are getting 2 black balls, that means you are getting 2 black balls and 0 red balls. Is it okay?
Yes, sir.
Now, no other values it can take. It won't take 3 because you can't take 3 black balls as there are only 2 black balls and we have to also withdraw only 2 balls. So we make a table here. In upper portion of the table, we put the values of X which are possible, and in lower portion probability distribution, we find probabilities. So what is the probability that that total number of ways are same for all of them? That is number of ways in which two balls are drawn out of seven balls. So that will be 7C2. Total number of ways of withdrawing two balls out of seven balls is same. Now, how many number of ways are there that you get zero black balls? So what it means that you are getting zero black balls means you are getting only two red balls. So out of five red balls, you are selecting two red balls. If you come to number of black balls, one, so that means that is you are getting one black ball and one red ball. So out of five red ball, you will take one red ball in 5C1 ways. And out of two black ball, you can take one black ball out in 2C1 ways. Similarly, if we are taking two black balls and both the balls which we are taking are black, number of ways is 2C2. So this is how we do this. Is it okay?
Yes, sir. Oh, so I'm not able to find P in the sixth one.
Yeah, what are you saying?
Oh, so the sixth one I'm unsure.
Question number sixth one.
Yes, sir.
Okay. From a lot of 30 bulbs, which include six defectives, a sample of four bulbs is drawn at random with replacement. Find the probability distribution of the number of defective bulbs. Okay. 6 are defectives and you draw 4 bulbs. Find the probability distribution of the number of defective bulbs. So number of defective bulbs can be, if you are taking 4 bulbs, so you can get either 0 defective bulb, or you can get 1 defective bulb, or you can get 2 defective bulb, or you can get 3 defective bulbs, or you can get 4 defective bulbs. So you can't get 5. Though there are more than 4 defective bulbs, but you can't get 5 because you are withdrawing only 4 bulbs. So you can withdraw maximum of 4 defective bulbs. Now their probability distribution. Similarly, the denominator part is same. That is total bulbs are 30, you are withdrawing 4. It will be 30C4, 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 30C4. You don't have to calculate this, you can leave it as it is. And numerator part is that you are withdrawing 0 defective bulbs. That means all the bulbs which you are withdrawing are non-defective. So non-defectives are 24. So the 4 bulbs are non-defective in 24 C4 ways. 1 is defective, so 6 C1, and rest 24 you get 3. Then you get out of 6, 2 into 24 C2. Then out of 3 defective, you are getting from 6 and 1 non-defective from 24. And lastly, all the 4 are defective. That is, we are getting 6C4. Are you getting it?
Yes, sir. Oh, so we can leave it as this, right? Like, is this the final answer, or we need to do the
Yeah, you
calculation?
can leave it as it is. You don't have to calculate them.
Okay.
Next question is 8, 9, 14. I'm coming in a minute.
Okay, sir. So in the eighth one, we can equate x to 1, right? Like all the k's is equal to 1. And then after that, we can find k.
Yeah, correct. Sum of all the probabilities are 1. Yes, Darnell, have you got the value of k?
So k is 1 by 10.
1 by 10. Okay, fine. So now you can put 1 by 10 there in place of k and get the probability distribution and do part 2, 3, and 4.
Oh, so the second one is 2 by
2 by 10.
so the
X
second
less
one is 3 by 10.
3 by
And the
10.
third one is 17 by 100.
17 by 100. 7 by 100 plus 1 by 10. Yeah, correct.
Oh, the fourth one is also 3 by 10.
Fourth one is also 3 by 10. 0, 2, 3. Only 1 and 2 will be there. Yeah, correct.
So for the ninth one, k will be 1 by
K will be
k will be 1 by 6.
1 by 6. Okay, x0, x1, x2,
And
and otherwise. So, yeah, 1 by 6 is correct.
and for the find p, the first one is 1 by 2, the second one is 1, and more than equal to 2 is 1 by 2.
Mm, Next one is 1, fine. And next to that is 1 by 2. Yeah, correct.
So how do you find the variance and standard deviation of X?
Okay, there is a question of variance also. So variance
Yes.
is no more in syllabus, so you can leave that part of the question, which is question number 14. Now you are doing.
Oh, yes. So it's find mean, variance, and standard deviation.
So variance and standard deviation part you can leave. Rest you can check from the back whether you have got the correct answer.
Oh, so mean I got a 17.5.
Okay, just check it.
Oh, so the mean answer is not there at the back. It's just the variance and SD, which is given.
Okay, let us check. The class has 15 students whose ages are 14, 17, and so on. One student is selected in such a way they each has the same chance of being chosen.
Oh, so the answer is given. The answer is given. It's 17.53.
Okay, fine then. So these were the last thing which we had to do. Now nothing else is remaining. Your syllabus is done as far as your chapters are concerned. So when is your maths exam?
So math is on 11th of March.
So you have a lot of time to revise, to prepare for even weaker portions and do as much practice as you can.
Yes. So do you have any tips for the inverse chapter, inverse trigonometry? Because there's like not much to learn from that.
There is no tips as such. There is basically the concept of principal value. So you have to just remember the angles should lie in the principal value. So if you will understand the concept of principal value like sine theta, it will be minus pi by 2 to pi by 2, cos theta 0 to pi. Similar manners, there are principal value range of other angles of other trigonometric functions. So if you will understand them, then you will get to know that there is basically all the properties and all the formula are revolving around that concept. You have to just basically understand that one, and then even if you apply any property or formula, you just have to relate it with the principal value.
Okay. So is at all for class?
Yeah,
Okay,
yeah,
fine.
we can. So, do you have class tomorrow also? Yeah, we are done with the classes.
So we have class on Tuesday. I'm pretty sure is the last session.